Hi, Leila. You are early today. How are you?
Fine.
Are you still in the mood of narrow celebration, Leila? Last time I think you had guests at home, right?
Yes.
Very good. So did you miss your school or you are enjoying your holiday?
We enjoy our holiday.
Leila, at school, your teachers, they are Azeri people or Russian people? Your teachers at school.
Azerbaijan.
But all your classes are in Russian, right?
Yes.
I see.
Our teachers in Azerbaijan, but some teachers teach we now speak with my class for Russian. Yeah.
Do you have a brother, Leila?
Yes.
What's his name?
Mahir.
Mahir.
Yes.
Oh, only one brother.
Yes.
Okay. How old is Mahir?
8. Yeah.
8.
Yes.
Very good. So he studies in grade 2 or 3?
3.
Grade 3. I see. Very good. Let's see, Leila. I think if the others join, we will continue. Otherwise, today we will have class only with you. Let me take my pen first. I need water. Leila, just a minute, okay? Let's
Okay.
wait for others. I think they are joining now.
Hi, Mr. Kasım.
Hello. Okay. Elmira, you are here, and Leila, you are here. Others, I think, they are in the mood of holiday. They forgot or they are busy. So we will start now. Okay. So all right. Good. Elmira, can you hear me?
Now, yes.
You can hear me, right?
Yes.
Okay. Leila, are you ready? Good.
Yes.
Elmira, Leila, last time actually we started this paper that is P5 from 2015, and we did a few questions. I think how many questions we did? I think 10, and okay, I think we stopped here, or even we did this. I think. Okay, Elmira, do you remember? Did we do this question? Not yet. Hello, Leila. Did we do this question?
No.
No. Okay, then let's continue from here. That's very easy question. Leila, read the question.
Which of the following statements is or are correct?
Which of the following statements or statements, maybe one or more than one, right? This which one is correct? Okay, read the first statement.
Um, Statement 8. 8 plus 0 divide 215.
2015, right? 2015 is equal to 8.
Yes.
Is it correct or not?
Mm,
So if you divide, for example, here we have, right, 8 plus, and here 0 is divided by 2015. What is it? If you divide 0 by any number, it is 0. And 8 plus 0, that's equal to 8. So this is correct, right? And how about the second one? Statement B, 8 plus 2015 is divided by 0.
it is correct.
It is not correct. Can we divide 2015 by 0?
No,
Eliminate.
we can.
Can we divide 2015 by 0? Like 2015 is divided by 0 is equal to what? We cannot. Why? Because
0.
it's not divisible by, I mean, we cannot divide any number by 0. Okay, so it is not correct. Actually, here we don't have such statement. This one is not correct. And the third one, if you multiply 0 by any number, it is 0. So 8 plus 0, that's equal to 0. So also that is, this one is correct. Only right question, I mean, which of the following statements are correct? Only A and C. So that is C only. Okay, Elmira, why did you say D?
Because I think that 2015 divided by 0, it will be 0.
No, we cannot divide any number by 0. We don't have 0 division. I mean, 2 over 0, it's not defined. We cannot divide any number by 0. Okay, if you say that, for example, let's say 2 is divided by, or 2015 is divided by 0, let's say you are saying 0, right? If you take this 0 to the right hand side, it will be multiplied. So 2 is equal to 0 times 0. What is 0 times 0 is equal to 0. On the left hand side, we have 2. On the right hand side, we have 0. Okay, so it is not defined. So the correct answer is C. B is not the correct statement. Okay. Okay, Elmira, is it clear?
Yes.
Let's move to the next question. Elmira, read the question.
Two numbers, x and y, are
Y,
such or
X and
equal
Y.
to 3, but less than or equal.
Read again, Elmira.
What?
Can you read a bit louder? X and Y, right?
But
Two
less than
numbers,
or
X
equal
and
to
Y.
6.
Okay,
Yes.
here, two numbers, X and
X
Y, are
is
such that,
greater than
okay,
x is greater than or equal to 3, but less than or equal to 6. Then y is greater than
Y,
or equal
Elmira,
to
Y, not
8,
Y, Y.
but y is
This one is
greater
Y, right? This one we read it as Y.
than or equal to.
Okay. So what do you think? How do you solve this question?
Find the least possible value of y minus x.
Okay, so the question is, we need to find the least, the smallest value of Y minus X. So in the question is saying that X is greater than or equal to 3, but less than or equal to 6. And symbolically, how do you write this? Here we
What?
have X, right? It is greater than or equal to 3. It is less than or equal to 6. And also, how about Y? Y is less than or equal to 10. It is greater than or equal to, what is it? It's 8. So now we are talking about the minimum value of Y minus X, the minimum value, the smallest value. For this smallest, we are subtracting, right? This Y should be the greatest and X should be, the Y should be the smallest, Y should be the greatest. What is the smallest value of Y? It is 8. As you see here, the smallest value is 8, maximum value is 10. So minus, what is the biggest value of X? That's equal to 6. So that's equal to 2. So the answer is, it is 2. So if X is between 3 and 6, Y is between 8 and 10, right? If you just find the difference, Y minus X, the smallest possible value will be X, 8, 2. Now,
Lucas,
if I,
can you hear me?
yes, Elmir, I can hear you. What happened,
I
Almira?
got problems with the internet.
Hmm.
And
Okay.
still now I can't see the questions. And like
Okay. Can you hear me now,
I
Elmira?
hear you. Now yes, but yes, now yes, but not but bad.
Okay. So, Leila, do you hear me well?
Yes.
Okay, now here, Elmira, Leila, if I just change the question, that's the first one. Okay, if I ask you this question, so what is, find the least possible value of Y minus X, right? How about if I ask not least, how about the maximum value of Y minus X? What will be your answer then? What is the possible, and what is the biggest or greatest possible value of Y minus X? What will be your answer? What would be your
X
answer?
X will be like 3 and Y will be 10.
Very good. So Y will be 10 and Y should be the greatest. X must be smallest. That is 3. So the answer will be 7. Okay, very good. So let's move to the next question. Leila, read the question.
Mm. A palindromic number is a whole number that reads the same forward and backward. For example, 100 to
1000.
1221 is a palindromic number. How many three digits palindromic number are there?
I think Leila, Elmira, we actually did similar questions for a few times, right? And now this question must be very easy for you. Leila, what do you think? How many three-digit palindromic numbers are there?
Mm,
Elmira, how many?
Mm, I have to think.
So, did you understand the question, Almira? For example, if you just write a few three-digit palindromic numbers, for example, what are they? Like, for example, we have 101, 111, 121, 131, 141, 151. I'll continue. The last one will be 191. And next one will be 202 and 212, 222. Continue, right? So these are the palindromic. As you see here, if you just read this from left to right or from right to left, it's the same thing, right? So now, in general, how do we actually make a new palindromic number, or how do we generate palindromic numbers?
Ah,
Suppose that we have to make three-digit palindromic numbers, right?
I
For the
find
first digit, we
90.
cannot write zero. Yes, Elmira?
90. I find answer. Variant B.
90, right? That's correct. So in the
Yes.
first one, except for zero, I can write any digit. Altogether, we have 10 digits, but if you just exclude zero, so here we have 9 possible things, digits. The middle one, it can be any number, right? It's symmetric, so I can write 10. But the first and the last, it must be the same, so here I have only one choice. So to find how many such numbers we have, just we need to multiply these possibilities. 9 times 10 times 1, that's equal to 9. So the answer is 90. Okay? Leila, did you understand?
yes.
Leila, if you understand, Elmira, if I ask you instead of this three digit, the same question, how about instead of this three digit, if I ask you, for example, how many four-digit palindromic numbers are there? What will be your answer? How many four-digit palindromic numbers are there?
Maybe 90 again. Or no.
90. Again, here we have four digits, right? The first one, except for zero, I can write 9 different digits, so I have 9. And the second one, I can write any digit. So the second and third, it must be the same. I can write only one because I cannot write different. So the second and third digits, they cannot be different digits, right? They must be the same. And also the last one, only one. So here, how many? 9 times 10 times 1 times 1. So that is 90. And how about
Mr.
if I
Carson.
ask you, Elmira, five-digit palindromic numbers? How many five-digit palindromic numbers we have?
Mr. Carson, can you hear me?
Yes, yes, I can hear you,
Maybe
Elmira.
um maybe 400 maybe or no.
No, 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 no. Elmira, you should understand this logic. Okay, here we have five digits, right? The first one again, except for zero, because if you write zero, it cannot be five-digit number. So it should be any digit different from zero. The second one, I can write 10. Also, the last one, I have only one choice and one choice. How about in the middle? I can write any digit, right? Because it's in the middle, it doesn't have any pair. So it's not dependent on any other digits. So I have 10. So how many here? So it is 9 times 10 times 10. It is 900. Now, if I ask a six digit, for example, six-digit palindromic numbers, how many six-digit palindromic numbers do we have now? Can you calculate it? 1, 2, 3, 4,
9
5, 6.
will be
How
like
many?
9.
So
The
that's
first will
9,
yes. The
10.
second 10. It will 10. Then
Okay,
1
1.
or 10.
Also 1, right? Because these two numbers should be
Uh,
the same.
wait.
These two numbers should be the same. And
And
these two
then
numbers should be the same. Also 1. How many? 900.
1. Mr. Carson.
Yes, Elmira.
Can you hear me? I can't hear you.
Really? Leila, can you hear me?
Yes.
Elmira, why can't you hear me?
Because now I have some problems with internet.
But I can hear you very well, Elmira.
Now, yes, I can hear you.
Hmm. Okay, good. All right, let's move to the next question then. Okay. Simplify the following fraction. That's very easy. Okay, can you try to do this? You have 1 minute. Elmira, D, are you sure?
No,
Leila, what is it? It's a very easy question.
Mm, I think they do.
Huh? You think what?
Indeed.
D?
Yeah.
No, no, no. Leila, here we have 1. We are dividing the 1 by this. So first we need to calculate the denominator. What is the denominator? 2 plus 3 over 4. That's equal to 4 times 2. 8. 8 plus 3, it's 11 over 4. Now next step is we should divide, right? 1 is divided by 11 over 4. And you know how to divide the fractions, right? Just we need to change the second fraction upside down. So here we have 1 times 4 over 11. 1 times any number is equal to itself. So that's equal to 4 over 11. The answer is 4 over 11. Okay,
Yes.
good.
yes.
All right. Let's move to the next question then. Uh, okay. Cheryl, Leila, can you read the question?
Cheryl wants to cut rectangle cards of length 4 centimeters by 3 centimeters from a rectangular sheet 30 centimeters by 22 centimeters. Find the biggest number of cards that can be cut from the sheet.
Okay. Did you understand the question, Leila?
Yes.
We are given a big rectangular sheet, right? Let's say this something like this. Okay. So the length is, it is 30 centimeters with 22. So from this, we are going to cut out small rectangular sheets, right? The small, that is, what is it? 4 by 3. The question is, find the biggest number of cards that can be cut from the sheet. How many such small rectangular cards we can cut out from this rectangular sheet? Elmira, 7? What do you mean by 7?
It's like the biggest number of cards that can be cut from the sheet.
No, Elmira, how is it possible? Yeah, for example, here, uh, 30, right? If I just well cut from here, let's say this one is, uh, this one, let's say it's 4. and 3, 1, 2, 3, 4. How many I can cut here? 30 is equal to 10 times 3. And this one is 4. So as a just from here, how can I cut from here? 40. Now, how about if I just divide, for example, let's say, not like this. Let's say, okay. So until here, for example, okay. So this one is, let's say it is 16 or maybe 20. Let's say if it is 20, we will 16. Let's say 16. Okay. So 16. So this remaining part, it will be 6, right? So now as see here, 16 is equal to 4 times 4. And 30 is equal to 10 times 3. Just from the shaded part, how many I can cut from here? So it is 10 times 4. I can cut out 40. And now we have remaining part, right? This remaining part. Also here we have some part here. So what is it? The length is 6 and width is 30, right? So now since it is 30, right? And I can just cut this into 2 because the 6 is equal to 2 times 3. And this 30, I can write it as 7 times 4 plus 2, right? And I'm just cutting. Suppose that you have a rectangular piece of paper and with scissors, you're cutting them, right? So here we have 7 times how many? Here we have 2. So that is 7 times 2. I have here 14 more. Altogether, how many? I can cut 15 more. So what is the remaining part? We have the small part left. Actually, here we have the length is 2, width is, what is it? 0. No, length is 2 and 6. So I have here only something like this, 2 and 6. This one is 2, the length is 6. The small pieces left. I cannot do anything with this. So altogether, we can cut 54. But Elmira, actually here, there may be some different solution. I don't know. If you can find 55, let me know. Because if you divide the area, right, 30 times 22, and divided by 4 times 3, we will have 55 point something. Okay, but how can we do that? Is it possible thing? If you can do this, let me know. Right now, I cannot see that because now, as you see here, this part, it is just wasted. I cannot do anything with this.
Mm.
Width is 2, it's not 4.
I'm find area of the big rectangle and the little rectangle and divided Arabic and divided little rectangle for big rectangle array.
But Layla, actually here, that method, it may be wrong. As you see here, for example, Layla, if I ask you, okay, this one, if you look at, look this one, right? So if you are given this kind of rectangle, for example, right? If you are given this kind of rectangle, let's say, okay, let's say we are given this kind of rectangle. Length is 2 and width is 6. What is the area? Area is equal to 6 times 2. That's equal to 12 centimeters squared. So now if you want to cut this kind of card, the area, it is 4 times 3 is equal to 12 centimeters squared. Right? Now you are saying that if you divide area by this area, it is 1. So now I cannot say that from this rectangle, we cannot count any paper whose dimensions are this. You understand, Leila? So just directly, if you divide the area and by this area, sometimes it may be possible, sometimes it may not be possible. It depends on these numbers, then 30 and 22. Are they divisible by 3 and 4 or not? If they both are divisible by 4 and 3, at that time we can do that. But here, it is not. Leila, you got 55, right? Okay, this 55. Leila, you need to show me how you are cutting the paper, okay? How you are cutting this. If you can show me at the time, I will accept. Otherwise,
Um,
Yeah, with scissors, okay, measure this 30 by 22. And how can you cut this? Let's see. Okay, let's move to the next question. Okay, Elmira, can you read the question?
Yes. The product of two numbers is 100. Neither of the two numbers has 10 as a factor. Find the sum of these two numbers.
Okay. So the product of two numbers is 100. Neither of the or neither of the two numbers has 10 as a factor. That means that each of the numbers are not divisible by 10. Find the sum of these two numbers. I think it's a very easy question, right? What are those numbers? Elmira, Leila. Huh? What are those numbers? Like, for example, it says 100, right? And I can write in a lot of different ways, but can I write it as a product of two numbers and each number doesn't have 10 as a factor? Like, for example, I can write it as 10 times 25, right? Is 10 divisible by 10? No. Is 1025 divisible by 10? No. So these are the numbers. Then if you add them, the question is, what is the sum of these numbers? That's equal to 29. And how about the same question instead of 100? Let's say if they ask 1000. Again, it's the same thing, but here, because this one is 2 squared and 5 squared, here we will have 2 cubed and 5 cubed, because here we have 3 digits. Okay, we have 3 digits, and at the time, this will be equal to, what is it? 8 times 125. And how about if you're talking about 10,000? At the time, it will be 2 to the power of 4 times 5 to the power of 4. And what is 2 to the power of 4? That is 30, not 30, actually, it is equal to, what is it? 16. And 5 to the power of 4, that's equal to 125. Okay, here, sometimes they may ask you, let's say 1000. And the product of two numbers is 1000, and neither of the two numbers has 10 as a factor. Find the difference of these numbers. They can ask like this. Okay. Leila, 100 times 0, what is it?
Numbers.
And what is 100 times 0?
Mm,
Huh? It is 0, right?
yes.
So why did you write 100 and 0, Leila?
Mm, I understand.
Okay, it says that the understand the question is very important. It says neither of the two numbers has 10 as a factor. That means that both numbers are not divisible by 10. So at the time, the only way to write like 10 or 100 or 1000 or 10,000, even 100,000 or 1 million is a product of two numbers where none of those numbers are divisible by 10. One should be the power of 2. The second one should be the power of 5. Okay, Elmira, is it understood?
Yes.
Good. Next question. Leila, read the question.
A circle and a triangle are drawn on a flat surface. What is the biggest number of the regions that can be formed on the surface?
A circle and a triangle are drawn on a flat surface. What is the biggest number of regions that can be formed on the surface? Okay, you have 1.5 minutes. We did this similar question before. Try this, okay? After 1.5 minutes, we will discuss together. draw this on a paper and let's see how many regions you can count. Leila, how many regions? Leila, I cannot hear you.
5.
5. Elmira, 3. Really? Why?
Mm,
Elmira, can you see the circle?
yes.
So now we are going to draw a triangle, right? Because it says a circle and a triangle are drawn on a flat surface. So our computer screen is the flat surface. So now I am going to draw a triangle now, like this. And after that, like this, right? And after that, like this.
But I think not just in one place.
Hmm?
Just like I didn't understand the question.
So it says a circle and a triangle are drawn on a flat surface. What is the biggest number of regions? What is a region? A region is a piece of, let's say, land or space that is surrounded by lines or curves, right? That can be formed on the surface. As you see here now, this one is 1. This one is 2. Sorry. This one is 1. This one is 2. This one is 3. This one is 4. This one is 5. This one is 6. This one is 7. And also, Elmira, Leila, pay attention. We have one more region, right? Where is it? It is outside, right? Also, it's one region. So how many regions we can actually make? We can make 8 regions. Okay, Elmira, did you understand?
Now, yes.
Instead of triangle, let's say, okay, instead of triangle, if I just write here Elmira, Leila, let's say, how about if I just write rectangle, for example? Let's say rectangle. What will be your answer then? Hmm? Let's say you draw a circle and a rectangle. Let's say a circle and a rectangle are drawn on a flat surface. What is the biggest number of regions that can be formed on the surface? What will be your answer? What would be your answer actually?
Mm, 5 or 8.
6.
How many?
Maybe 6.
6?
Yes.
Are you sure?
5.
No. Maybe 7.
7. Maybe
7 or
7.
6.
Maybe. Look, here we have a given circle, right? This quadrilateral or rectangle. I can draw like this. Not like this. Let me draw a nice circle here. Okay, that's our circle. Now let's draw a rectangle. Okay, rectangle like this. Not like this, sorry. Because I want to draw from here. Like this. Okay. So now if you look at this, how many regions we have again? 1, right? Let me just put dot. 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, Elmira, can you see that?
Yes, but I draw like a little bit
I mean, did
another
you
rectangle.
understand the question? Did you get it?
Yes, I get it.
Good. So now the last question. Okay, the last question. Let me just move to the next one. Okay, let me just wait. All right. Okay, so you understood. Now the last question. Okay, I hope you can answer this question correctly. And instead of a circle and a triangle, okay? Tissue. Okay. Okay, Leila and Elmira, instead of this a circle and triangle, how about if we draw 3 circles? Let's say the question is 3 circles are drawn on a flat surface. What is the biggest number of regions that can be formed on the surface? Come on, if you answer correctly, I will give you gold medal, star.
Ten?
10?
Yes.
No, more than 10.
Mm,
14.
How many?
14.
14. Are you sure, Leila?
No.
I mean, did you really get 14 regions, Leila? Did you count 14?
Yes.
Okay, the 14 is correct answer. Right, just because to draw, to get the biggest number of regions, the circles should intersect each other at 2 different points. So if you draw like that, for example, let's say that is the first circle. Okay, and that's the second circle. Let's say this one is second circle. All right, and I'm going to draw the third circle here. Let me draw like this. So now, if you just count the circles, how many? Let's start from here. 1, the smallest one. Okay, this one is 1, right? This one is 2. This one is 3, 4, 5, 6, 7. Is 8. How did we get 14?
Mm, no,
It is 8. If it is 3 circles, it is 8. Leila, your answer is if you draw 4 circles at the time, it will be 14. 3 circles because I cannot make more regions. And the last one is 8 here. So we have how many regions? 8 regions.
yes, I'm drawing four circles.
Okay, in 3 circles, it is 8. 4 circles at the time, there will be 4. Okay, Elmira. All right, if it is understood, let's move to the next question. Leila, read the question.
Yes, okay.
Mm, a train travels at the speed of 60 kilometers an hour. The length of the train is 100 meters. Find the time taken by the train to pass complete through 1 kilometer tunnel.
1 kilometer tunnel. Okay. Here, actually, here we have 1 kilometer tunnel. Let's say it is a kind of tunnel here. All right. So the train is coming, right? This is our train is coming, and it has a length, right? So the length of the train is 100 meters. It is 100 meters. And it says that the length of the tunnel, it is 1 kilometer. 1 kilometer, right? So the question is, find the time taken by the train to pass completely through a 1 kilometer tunnel, right? Actually, the train is entering. Now we just start counting the time. And after that, it just leaves. From here, it leaves the tunnel, right? So this is a leaving point. So that means that when he leaves, he will have traveled. What is the distance here? Because also we need to include the length of the train. And the length of the train in kilometer, because 100 meters, that's equal to 0 0.1, what is it, kilometer. So the total distance traveled by the first wagon of the train, right? Because here it is entering, but the last wagon is leaving here. So the total distance traveled by actually the first wagon of the train will be the length of the tunnel, that is 1 kilometer, plus the length of the train, that is 0 0.1 kilometer, which is equal to 1.1 kilometer. Okay, so now the question is, we need to find the time taken and the speed of the train. The speed is 60 kilometers per hour. And how to find the time? Time is equal to distance over speed. Distance is 1.1 kilometer and time speed is 60 kilometer. So if you divide kilometer per hour by kilometer, here the unit is hour. So now if you change this into hours, so 1.1 over 60, 1 hour is 60 minutes. So I can change 1 hour into 60 minutes. So this 60 cancel each other. That's equal to 1.1 minutes. And of course, we don't write like 1.1 minute, right? So we need to also change 0.1 minute into seconds. And 0.1 minute is equal to 0.1 is 1 over 10 times, how about in 1 minute we have 60 seconds, which is equal to 6 seconds. So the answer is the train passes through the tunnel in 1 minute and 6 seconds. Leila, 1 minute and 6 seconds. Not only 1 minute. Okay, Elmira, did you understand this question? Because here, in this kind of question, the main idea is First, we need to find the distance traveled by the train, or that's the first wagon of the train, because when it's entering, right, the first wagon and leaving the last wagon. So that's why the distance is always the length of the tunnel plus the length of the train. And to find the time, we need to divide the distance by speed. Okay. All right. Leila, Elmira, I will finish the class here. Okay. We will continue next time. Leila, try to practice more questions. If you don't understand any question, let me know. I can explain one more time. One more time. We have only like 4 weeks left. Okay. And try to practice more questions. And also the past questions sometimes. I mean, if you didn't understand, try practice one more time. If you still don't understand, let me know. We will solve them again. Okay. Elmira, Leila, have a nice weekend. I will see you next Monday. Okay, have a nice weekend. Enjoy your holiday.
Mm, Thank you for listening, Mr. Kazim. Bye bye.
Thank you, Leila. Bye bye.